Hello everyone, myself Imranjeet, and today's my project is Embedded System. In our 1 year internship, we have learned by the IMATIs that is presented by me, Imranjeet Rai, and our new and here the detailed explanation of embedded system. What is embedded system? A combination of computer hardware and software and other additional mechanical parts designed to perform a specific dedicated function with a larger system. It is like a system which have many parts like user control, manual control, and AI control. In embedded system, we have also read about the ADAS, that is Advanced Driver Assistance System, in which it is used to monitor the uh, intelligent safety of technology. Here is the key characteristics. First is real-time orientations that responds to the input of this strict predictable time limits, and second is dedicated functions, and third is resource concentrated, and fourth is low power, high reliability, and tightly coupled SW and SS. Now we have the basic architectures. The basic architectures of embedded system contains the sensors, which is input part, and also have input interference, which have ADC, signal conditioning, which can directly convert the signal, and third is processor and controller, that is CPU logic, core logic, which is used to store the memory part, and fourth is output. What we have done in ADC, the output is given that to the driver, and the fourth one is output unit. In memory, there is a RAM and ROM. Both are used. In firmware, hardware, software control the logic power supply, that is battery DC source, which is used to control the embedded system communications, that is UART, SPI, 12C, Wi-Fi, and Bluetooth. These are used to control the embedded system. For basically, the Wi-Fi, Bluetooth are connected through the sensors that is remotely used by the users and driver. A microcontroller and microprocessor. There is a core hardware component, that is microprocessor and microcontroller as a memory. It has also a memory part, that is RAM, ROM, flash. It has actuator, sensor, input, output, interference, and communication models that are UART and other we have seen in previous slide. Here you can see the previous slide. We have seen the UART, SPI, 12C, Wi-Fi, and Bluetooth. And the sixth is a software layer from the raw hardware to application logic. Application layer, RTO scheduler optional. Device, driver, hardware abstractions layer, hardware, MCU, and MPU. And the seventh slide are classification of embedded system. Basically, embedded system are classified into four types. That is standalone, real-time, network, and mobile. The standalone takes a input process and give a output independently. Example: microwave oven controller that have a timer set which is used to cooking the food. Real time, most of the respond limit of stuck deadline and split into hard RTS and missed deadline failures of soft RTS. Network connected to a network to share data or resource communication in ITO devices. While portable battery powered systems such as smartphones and cameras. And next our slide is about what is the difference between microprocessor and microcontroller in embedded system. Basically, microprocessor and microcontroller. The integration part of microprocessor is CPU only, where microcontroller have a RAM plus ROM, that is output in one chip. Microprocessor cost and size. The higher system cost, board areas, and micro compact lower overall system cost. Power use. What is the power use of micro? The power high power to consumption, where microcontroller optimized to low power, and microcontroller typical use, that is general purpose computing, POS server, and microcontroller have typical use of dedicated embedded control tasks. The example of microprocessor are Core, Intel, i5, AMD, raise. And the microcontroller example that is RM, Cortex M, PIC, AVR, Arduino. And the next slide is about embedded system deployment cycle. How the deployment cycle is produced. There is a requirement, hardware design, firmware deployment, integration testing, and validations and deployment. And next slide is about real world application. What is the embedded system where it is used? Here we have real world application. We use the or we use in automotive industry. We use in healthcare. Also use in smart homes, consumer electronics, and industrial automation. Also use in space and defense, IoT and networking, banking and retail. These are the applications used in our real life. And the next, advantages and challenges. What are the advantages using embedded system? Their compact size and lightweight design. And what is the challenges? Limited processing power and memory. Advantages: low power consumption, ideal for battery, difficult to upgrade once deployed. High reliability with dedicated function, complex hardware and software. This is the challenges: complex hardware and specified debugging. And the other challenge is longer deployment testing cycle. Advantages: fast real-time response. There is a fast real-time response in embedded system. Lower unit cost. The lower unit cost in embedded system. And the challenge is security is hard to patch post-release. There is no much high security about this. So our next slide about the future trends. Future trend AI, that is AI. We use in AI, IoT expansion, security designs, and ultra low power RICV, custom silicon, and 5G connectivity. Next is about recap. What we have learned during the internship about emerties. We have made the three projects. One of the EV control module. In EV control module, we have learned about the speed model, SOC estimation, range estimations, driver modes, regenerative braking, and thermal braking. These are the terms we used or we have learned in the MRT's internships. And next is our next project is Blink LED and GPIO Basics. We have host and targeted ARM Cortex family and GPIO pins. HAL, GPI, right pins, and we have used this of these to use the now let I see you the project blink project. This is the LED blink project. Here we use LED in Pixsim Lab. The LED is blinking here. You can see this. The LED is blinking here. Now the next project is about ADC on STM. What is ADC? Basically convert the continuous analog voltage into a digital number and MCU can be used. There is a 12-bit mapping and cube setup, QMX setups and reading channels scaling value, UART output, where we use the UART output. Here the ADC system where you use the potentiometer meter 0, 1, 0, 2, 1, 2, 3. There is a four type of potentiometer we used. If we increase the potentiometer 0 to this 0.33 and potentiometer 1 to 0.66 and potentiometer 2 5.07 and potential 3 is increased about 5.46. So here we can see the value in it. So the next is ultrasonic sensor. We have also learned about the ultrasonic sensor during our internship. Here, how it is work and what is ultrasonic sensor. Send a pulse. Basic ultrasonic sensor used to send a pulse, which is used for sound burst and wait for echo, measure the time, and calculate the distance. So here is the cycle, which easily can be understood through this. You can see. At last, I would like to thank the Emerties for giving me this chance and attend all the classes. And I am very excited to learn new things about Emerties. Thank you, Emerties, for this project from Indri. Thank you.